We're going to continue with factoring of trinomials, but this time it's going to get a little trickier. It's going to get a little trickier because now you're going to be having what is called a leading coefficient. In the problems that we did on the Friday before break, you never had a number there. It was always just x squared. So we're upping the game and we're bringing it to the next level. The rules don't change. This is step 1, 3x squared. We know since it's a trinomial, it always factors into two binomials. We learned that. So 3x times x is how I get 3x squared. 8. Remember we went over how to create the factors of 8? So I'm going to do something here. I know it's going to look a little odd, but 1 times 8 and 2 times 4. Now I made them in different colors so I can move them. So I'm going to start by putting the 1 and 8 in here. Notice what happens when you have a leading trinomial. It triples whatever number is in the back. So even though 3x times x gets me 3x squared and 1 times 8 gets me the 8, I need my bridge and tunnel to get a -2. So this would be 24x and this would be x. They're like terms, and could they ever combine together to get a 1? No. If they were both positive, a 24 plus a 1 gets me positive 25. If they were both negative, it'd be negative 25. Well, how about if I subtract them? Make one negative and one positive. Well, 24 minus 1 is 23, and if it was negative 24 and positive 1, okay, that number doesn't work. But you're not done with 1 and 8. Because if you switch their spot, put the 8 over here and put the 1 over here, you get a totally different bridge and tunnel. 3 times 1 would be 3x. 8 times x would be 8x. Can a 3 and an 8 ever get me 2? No, they could get me a 5 or an 11. So now I know that 8 and 1 are definitely not my choice. How about 2 and 4? Well, the same thing's going to happen. If I put a 2 here and then a 4 there, my bridge is 12x, my tunnel is 2x. Can a 12 and a 2 ever get me 2? Nope, 12 minus 2 would be 10, 12 plus 2 would be 14. But we're not done with 2 and 4, because look what happens when I switch their spots. Now it works, because this leading coefficient 3 triples the 2 to 6. 4 times x is 4x. Can a 6 and a 4 ever get me a -2? Yes, if the 6 is negative and if the 4 were positive. All right, so that means the positive is down here in the tunnel, and the tunnel connects to this. The 6 is the bridge, and it connects to that. So my 3x plus 4 and my x minus 2 is the correct factorization of this trinomial. Now you can do all this bridge and tunnel the same way if you like the boxes and the Common Core way. It's just you'd be putting the 8 here and the 1 here, and then creating your boxes and trying to see if this diagonal gets put together to make your middle term. All right, example 2. Same thing. 3x squared. It's a trinomial, so I know it's going to be two binomials. I know this is 3x. I know this is x. And look, we've got 8 again. So we've got 1 times 8 and 2 times 4. All right, let's see if we can do this a little quicker. Well, that's 24 and 1. Nope, that can't get me 10, but I have to switch their spots. So let's see what the bridge and the tunnel has for now when we switch their spots. So now the 1 is getting tripled, so it would be 3x. And then 8 times 8 is 8x. I'm sorry, 8 times x is 8x. Can an 8 and a 3 ever get me 10? Close, it gets me 11 or a 5, but not what I need. So the 8 and the 1 were in our choice then. I'm going to go with the 2 and the 4. 3 times 4 is 12x. 2 times x is 2x. All right, can a 12 and a 2 ever get me a positive 10? Yes, if the 12 were positive and the 2 were negative. So the 12 is connected to the 4, so that gets the positive. The 2 is connected to the x in the tunnel, so that gets a negative. And I'm factored. 3x minus 2, x plus 4. 3x times x is indeed 3x squared. Negative 2 times positive 4 is negative 8, and we already know the middles work, so I'm good. Once again, if you like the Common Core way, you'd be using the boxes. All right, so in the classroom the other day when I asked which way you preferred, everybody said bridges and tunnels. So I'm just going to stick with bridges and tunnels. In example 3, gosh, I'm liking the 3x squared a lot. Well, there's a reason why. You won't find out until tomorrow. It's a trinomial. We know trinomials are factored into two binomials. So this is going to be 3x and x. Now over here I'm going to list my factors of 14 because that's what comes next. Step 2. Well, it's 1 and 14. It's 2 and 7. And that's it. Or at least they're small. I don't have that long list. Well, let's see. They've got to be only one away from each other. Let's put 1 and 14 down. My bridge is 42, because 3 times 14 is 42. My tunnel is 1x. Can a 42 and a 1 ever get me 1? Nope. Switch the spots. Let's see what the bridge and tunnel have in store when I switch the spots, because now the 1 is getting tripled and the 14 is not. Can a 14 and a 3 ever get me that coefficient of 1? Nope. So goodbye 14 and 1. It was a nice try. Let's bring down the 2 and the 7. Well, let's think about this. If I'm putting the 7 here, I'm going to end up tripling it to 21. And all I have left is a 2. So a 21 and a 2 is never going to get me anywhere near 1. So when you become more adept at this, you can kind of guess and figure out where the numbers really have to go. Because when you're going to put the 2 in there, that means it's going to get tripled by the leading coefficient of 3 and get me 6x. And then 7 times x is 7x. Can a 7 and a 6 ever get me 1? Yep, if this is negative. And then this 7 would be positive. And there, I'm factored. I can check myself. I already know my middles work. And just to double check, 3x times x is indeed 3x squared. I already know my middles work, and I want to check, does positive 7 times a negative 2 get me a negative 14? Beautiful. All right, one last one. We know it's a trinomial, and as you notice, we haven't done any greatest common factor or conjugating of difference to two perfect squares because we want you to get used to how to factor a trinomial quickly. So we know it factors into two binomials, a leading coefficient of 2, so it's 2x and x, and now 36. Wow, there's a lot of numbers that multiply together to get me 36. 1 and 36. 2 and 18. And remember we talked about this. You have to move through your factors this quickly. You can't be sitting there going, oh, does 4 go into 36? You have to move this quickly. Those are all your possible combinations that multiply to 36. All right, now I need to get a negative 21 in the middle when I add these factors together. So I know one of these factors is going to be doubled. And this is where you start kind of analyzing. Well, if I double 1, it becomes 2. Can a 2 and a 36? No. And if I doubled 36, it'd be 72 and a 1, so we can cross that one off. If I double 2, it's 4. Can a 4 and an 18 get me to 21? No. And if I doubled 18, it's 36. Can a 36 and a 2 get me to 21? No. 6, so if I double 3, and you know I'm doubling because I know I'm going to get doubled down there. That's where I'm getting this doubling from. This is how we start to go quickly. Double 3 is 6. Can a 6 and a 12 be 21 away? Well, 6 and 12 is 18. I'm close. I know I'm close. How about if I double 12? 12 doubled is 24. Hey, I think I got it. So I just said if I doubled the 12, that means the 12 has to go here. It gets me 24. The 3 goes here. Can a 24x and a 3x ever get me 21? Yes, if this is negative and this is positive. So this would be the negative 12 and this would be the positive 3. Now, if you didn't like how I did that all in my head, feel free to do bridges and tunnels for each one. But we really want you to be able to start when you become more adept at this to once you see all your factors listed out and realizing that one of the factors is going to be doubled because it's a leading coefficient of 2, that you can start doing the doubling in your mind and figuring it out from there.